first time, I found it very difficult to watch because if you're a fan of the book, the movie is very good, but they literally change everything from the book, everything. So you find it very frustrating to watch it because you're like, oh, I'm so confused. I don't know what's going on. But then when I went and saw it the second time, I was over the shock. I mean, it's really good. I mean, you can kind of understand why they changed stuff because it would play better for the big screen.
Right.
Mm-hmm.
But yeah, I thought it was really good. Yeah, but my experience has been they change like in the movie. If you haven't seen it yet, there's like these 3 challenges. I'm not going to tell you what they are, but the 3 challenges in the book and the 3 challenges in the movie don't even represent each other. They don't resemble each other. They're not the same. Well, look for the email blast from that Grace. Yeah, so they're having a movie night next week. What is it? Is it Tuesday next week?
Yeah, Tuesday, 7 o'clock. The deadline to sign up has now been moved to Thursday, so tomorrow. So talk to Alexis.
Yeah, either Alexis Rollins or Stephen Cario. Either way, if you look at the email, I think Stephen's email address on the bottom of it. $5. They'll. I think they're even doing a thing now where they'll, for the first several who sign up or something, they might cover your ticket or something. I don't know. I might be making that up. But it's $5. And I'll probably go with them for that. So, if you bribe me enough, I'll have 4 extra tickets.
What's the movie they're going to see?
Ready Player One.
So do you think it was like that they switched it up completely, the challenges, or do you think that was like kind of?
I think it was Steven Spielberg saying, "Look, what your challenges in the book are make a whole lot of sense for a book, but won't make sense on the big screen."
Yeah,
which is true.
Yeah, like the race was probably more interesting.
Yeah, I mean, in the book, the first challenge is you play Joust.
Yeah, who wants to watch Joust?
Who wants to watch Joust for a half hour on the big screen? I mean, if you're a huge fan of the book, you would find that interesting. But if you're sitting there and you're just random moviegoer and you're wondering, why am I watching a 1980s crappy video game being played on the big screen for 20 minutes?
Did you solve any of the challenges before he found out the clues?
To who?
Did you solve any of the...
They're different than that. It's not like a clue thing. I think if you read the book, you maybe would make some of the connections. But I mean, the first challenge is meaning. I mean,
First challenge I didn't get.
well, it's just inserted. It's like they reference that somebody had previously found the clue that unlocked it or whatever. But the first challenge doesn't make any sense from a. It was just their opportunity to show cool CGI stuff.
Still really wish we had kids in that.
Well, I mean, I've heard some people say they should have made it into a trilogy, where first movie would have been the first gate, but that's a risk. I mean, you got to consider this is, it's a single book. They didn't know how well it was going to do with the box office. I think in hindsight, it would have probably played out okay for a trilogy, but I think, probably most people who went and saw the movie did not read the book. So most people who go and see the movie are going to like the movie. I think a lot of people who have read the book, if they only saw the movie once, are not going to like it. They're going to be very frustrated by it. But I'm not sure it would do well as a trilogy. The book people want that. I'm not sure the moviegoers necessarily want that.
There was only one book.
Only one book, but it could be split into 3 movies from the book people's perspective. Like, oh, you need so much more detail and stuff like that. At the end of the day, the movie did a pretty good job of capturing the feel of the book. It just missed a lot of the details. All right. So let's see. Does this thing close? I'm having that eye thing. I can't see again. All right. You're my eyes.
Oh, no. Okay.
What are you looking no, for? I can mostly. Oh, look at remove more closely. Okay. So we were looking at, let's see what we were trying to do here. So we were changing a list. So we created an empty list here. Then we printed out we printed out the list. Then we went through and we added a bunch of crap to this list. These are random numbers between 0 and 10, 10 inclusive, right? So this is how we generate random numbers if you want to add that to our toolbox. Then we went ahead and we just modified bucket 0 of that one to be -5. And we also modified the very last element of the list. So that's the length of the list minus 1 is the last legal bucket in the list. We set that equal to -5. Then we appended a -100 after that. And then we printed out the word after and spun back through and printed out the elements of the list all on one line. That's why we did the little space thing here. Okay. Then we came down here. We started another loop. We printed out, so this is a for each loop. So this is us going through each element of the list, indexing using I. So we took I on a voyage between 0 and the number of elements in the list minus 1. Each time through, we access the individual element at that bucket in the list using I. So this says, give me the element that lives at bucket 0. Give me the element that lives at bucket 1, lives at bucket 2, lives at bucket 3. So each time through this loop, I is changing. And the alternative to that is this guy down here. This is a for each loop where we're saying, I have a collection called my list. And each time through this loop, I want val to be the next element in my list. So what we lose here is we lose the ability to know where in the list we are. We don't know if we're at bucket 0 or bucket 2 or bucket 7. We just know that val is equal to the next element in the list. So I printed out val here. And then if we wanted to keep track of where we were, I threw in this extra variable j, and we just had j increment each time through the list. So we technically did know where we were because I added this little bolt-on feature. Gave myself an extra variable that would change throughout the loop to keep track of it. All right, but these are two, this loop and this loop will have the identical output. So, and we can even say they're mostly interchangeable. You can use either one for most problems. But if you happen to need to know where in the list you are, the position that you're currently looking at, you'd want to use something that looks more like this. And then use that bucket, use the index I, that integer, to say, give me the element at this place in the list. That way you might want to remove something from that element or that place or something like that. If you don't need to know where you are in the list, this is a pretty convenient way of zipping through a collection of stuff. Just saying, look, I want val to equal each element of the list, go. And each time through, val's the next element. Okay? All right, so then we decided we're going to create something. We're going to try to remove a value, 10. And then we went through this list and we looked at, if we're looking at the element, so this is our first style for loop, the one that actually counts. So this is I is 0, 1, 2, blah, blah, blah. Then we asked the question, if the element I'm currently looking at, the element that lives at position I in the list, is equivalent to the value that I want to remove, which is this guy right here. If it's equal to that, then I want to remove from my list. And we had a weird behavior with remove, so that's why I put this comment. Let's look at remove more closely and get a clear idea on how remove works. So what I'm going to do here, just for a moment, I'm going to cut all that stuff. I have it. I can paste it again in a second, so don't let me copy anything else. All right. Actually, it wouldn't be the end of the world. I'm going to go ahead and I'm going to create a new my list. And I'm going to have this guy equal to 1, 2, 2, 3, 2, 4. So something that has several 2's in it. All right. Then I'm going to go ahead and I'm going to say print my list. And then we're going to say, what is it, str.remove. From my list, I'm going to remove a 2. And then I'll go ahead and print my list again. All right, the vision and the typing are bad today. Okay, there we go. All right, so let's see what this guy gives me. Because what we're really doing is we just came home from Home Depot. We bought this tool because it was on sale. All right, and now we want to know how exactly does this dude work. Okay, go ahead.
Is the list going to record properly about the commas in between the numbers, or is it okay like that?
I don't know. We have to put commas in? I don't think you have to put commas in, do you? Let's find out. Ha! All right.
Nice.
This was on our desktop. Yeah. All right. Does not like that, so it must need the commas. All right, and this guy would be called a list literal. That's what I'm creating there. So I'm creating a list and I'm hard coding in initially the values of it. I could still append to that list, but the type of animal I'm talking about here is this is a literal. Thou is equal to 7. This is a literal. So anytime we have a static value like that, those are literals. All right? Not that important that you remember that exact word, but it's more important that you know what that means so that when you read it someplace else, you know what they're talking about. All right? Because literals kind of sound like kind of almost a fancy schmancy word for some reason. Yeah.
Can you explain that STR? Does that stand for string?
Yeah, so we have this library called string, str. So in that library, we have a bunch of functions, and one of those functions is remove.
So you have to specify what kind of thing it is?
Well, for right now, just assume that the only remove we have belongs to strings. Although, hold on, we're not removing from strings, we're removing from a list.
So you're removing 2 from my list, right?
Yeah, but
That's not-
I need to do list.
Can we do my list up here?
Let's
So
find
you're-
out. Well, actually, hold on. Let's use whatever. I think we looked at this last time. Let's use whatever the book uses for remove, because I think the book introduces a remove.
Top or remove.
I want to remove a specific element. So here's lists and dictionaries, list methods. That's adding elements. Here's removing elements. So it's list dot remove. So whatever your list is, dot remove X. That's what we're looking at. So this guy right here, that's if we want to do something to strings. There is a string library called remove, but that's not what we're using here. So thank you for pointing that out. So we're going to say my list dot remove that. And actually that difference there, let me just talk about this for a second. Doesn't matter what we put in here. This kind of actually shows us 2 different styles of functions that we can write in programming languages. So this guy would be called a method or a function, but this guy would be called an instance method or a function because I'm calling this function by using an instance of the type that function belongs to. So this function remove is used for operating on lists, and I'm using an actual list to call that guy. All right, I'm using an actual list to call that guy. So I'm saying my list, remove from yourself the value 2. Down here, instead of this guy knowing about a specific string, we're saying string library, remove from. I would have to provide this guy a string as well as the value I want to remove. Yeah.
Don't you still have to specify my list when you remove it?
I don't think so. Yeah, see, the list here is the name of the list. So here's like my list dot remove. So, they're showing us a copy of this thing here. Maybe that was the problem I ran into last time. I was trying to do string crap on lists. That was right before break. Give me a break. Plus, that was the vision day, right? Yeah, so, but I want to see, does it just remove the first element or does it remove all copies of that? So the example they've given us here is, so this guy says removes the first item in the list that matches that. Well, if you have multiples of these, we might want to, but keep in mind, this guy is removing the 8 from here. What if I want to remove at a specific place in a list? That's going to be a little bit...
When you change the index,
Well, this isn't an index. So this guy right here is he is a value that we are searching for in the list that we want to remove. So this isn't saying remove bucket 8. This is saying remove the first 8 from the list. List pop only returns the last item in the list. Oh, here's one. Remove and return item at position I in the list. Yeah, this is the guy we actually want. So let's look at the couple of guys using our example here. All right, so if I say remove 2 here, what we should have left is the list 1, 2, 3, 2, 4, because this 2 has gotten removed. Makes sense? Only the first 2 will have been removed. So let's test that here. So there's the original. There's the one with the first 2 removed. Now, as an alternative to this, if we say my list dot pop, and let's say this is bucket 0, 1, 2, 3. Let's go ahead and let's actually do 4. That way we're not matching 3 with 3. So I'm going to pop bucket 4 from this guy, which should get rid of this 2 right here. Okay, because this is bucket 0, bucket 1, bucket 2, bucket 3, bucket 4, bucket 5. There's 6 total elements in this list. The legal elements are 0 through 5. Let me test this real quick and then. All right, so that last 2 was removed here. So we removed bucket 4 from that list. So the pop given a value allows us to target an individual place in a list and say, get rid of that place. And then the remove function allows us to take a value and it removes the first version, the first element that matches that value. Yeah, go ahead.
So when I use list.remove, it still wants me to specify that I'm removing it from my list.
Yeah. So what you're doing, notice I'm saying my list dot remove,
Yeah.
not list. If you have a variable called my list, you can't call it list.
That would be
That's a stranger. He doesn't know about that guy. So what he's doing is he has this thing called my list, yet he's trying to type the exact thing that's in the book. He's typing in list.remove here, and there is no variable named list. We have a variable called my list. So the assumption the book is making is that you already have a variable whose name happens to be list that has a list in it. All right, so that guy's not going to fly, so you would replace that with the name of your variable that happens to hold your list.
okay. That'd be
Could be elephant, could be, whatever you name your variable. That's what you would put there. Okay, and then pop, let's just look at the other version of pop. This guy, since it said the end, I'm guessing it's going to remove the 4. It's going to either remove from here or going to remove from here. Pop is a common function for what's called a stack data structure that we'll talk about in CSC200. So 2 classes down the line. And it always pops from the top of the stack, so it depends on how they're treating the top. Is the top this element or is the top this element? By the book's description, it sounds like it's the end, so this should probably remove the 4 from the very end. Yeah. So when we popped, it took the very last element of the list and removed it. Make sense? So those are the 3 functions that the book has introduced for manipulating lists from our perspective. Well, let me open up Keynote here. I'm going to put them into the notes here. You'll see it in a second. So let's go down to our toolbox. Whoa, what did I just do?
So it doesn't specify the bucket. It's just
All right, so I'm going to show you the three functions here. Let's just go down to our.
Index the list inside of pop,
right.
and then it will go to that specific spot. Otherwise, it'll
All right.
the last one. The default is to do it. Like
So we'll say toolbox
If there isn't a value.
list functions.
Value in the list isn't-
All right, so we'll show our 3 different list functions we have in here. So one function is called remove, and remove takes in a value, and this guy removes the first element. So I'm gonna type it like this: my list removes the first element. Now keep in mind here that my list is the name of whatever your list is in your program. Okay, so this guy removes the first element from my list that matches val. So, for example, if my list was 2, 3, 2, 4, and we called my list dot remove 2, this would leave us with a 3, 2, 4. It would remove the very first occurrence of the 2, which it finds at bucket 0. All right, so that's what remove does. Searches for and removes the first occurrence of an element. Now, my list dot pop, like that, removes the very last element in the list. And then we have another version, my list dot pop, that takes an index, and this removes the element in my list that lives at position index. All right, so 3 functions that we have. So really look at these from the perspective of, kind of real life tools. You run out to Home Depot, you're looking for something to solve some problem around the house. You grab something off the shelf, you come home and you figure out, how can I apply this to the problem I'm trying to solve? That make sense? All right, so now we have these 3 little tools that we can use. We are probably not in here going to find a use for pop that often. The plain Jane pop. But popping at an index we will probably find fairly useful. All right, now one other thing I want to confirm and show you here is that when I pop something, I'm going to go ahead and print what I popped. This guy, very likely, I'm sure I can go look at the reference, but I'm pretty certain this guy, he will pop the 4 off the end of the list, but he'll also return that 4. So if I happen to want the element that's at the end of the list, but I also want it to be removed from the list, this same thing will work. But in this case, I'm going to go ahead and print it. So this should print out a 4, and then it'll show my now modified list that is missing the 4. Make sense? Let's run that, make sure it does what I think it does. There's my 4. So we popped the 4 from the list. We printed out the result of pop. And the result of pop actually did give us the value it just removed. It yanked it off the end of the list and said, here it is. Okay, if you want this, I got it. And we decided to print it. Before, we weren't doing anything with it. We were just going, and then it just kind of flew through our hands, so we just let it go. Okay, we could throw it in a variable and then use it later. If we want to throw it in a variable, we can, we can do something like the val is equal to this. And then if I want, I can print out the val. So now, instead of printing it directly, I'll remove it from the list. I'll catch it into this variable. So the val will be equal to 4. Then I'm going to go ahead and prove that the val is equal to 4 by printing out the contents of that variable, the val. So you'll see we've got the same output here, but the means, how we got that output was a little bit different. All right, so pop indeed removes something from the list. Let's make sure the other version of pop does the same thing. I believe it should. I'll go ahead and pop, I'll pop from position 2. So that this is bucket 0, bucket 1, bucket 2. So I'm going to remove that element from the list. So make sure you make that distinction in your mind that with pop, we're telling it the location of the element we want to remove, as opposed to the value that we want to remove, that we use with remove. All right, so this guy should remove this 2, We're going to store that 2 inside of the val. This should print out 2. And then when we print out my list, we should be left with 1, 2, 3, 2, 4. So there's our 2 we removed, and there's our 1, 2, 3, 2, 4. So pop has a consistent behavior where when you remove something, it gives you the element you removed. If you want that and you want to do something with it, you can, but you don't have to. Okay? And then for remove, we'll go ahead and say the val is equal to mylist dot remove from position. I'm sorry, not from position. Dot remove the first occurrence of 2. So this guy will remove that guy who actually lives at bucket 1 because that's the first place that we find the value 2. Okay, so he'll remove that value from the list. We'll see, does he actually give me the value or is this just the perma remove? I believe he'll probably give us the value. So we'll print out proving that we got the value. Does not. So when we call remove, does not actually return the value to us. So we get a value of none. That's the default value for an empty variable. So remove doesn't give us the answer.
So
Yeah.
if it's none, what is it stored in the variable?
Say this again?
You mentioned it's none, but then is it store like the string none in there? Or what is
No, none is literally nothing. So in other languages, it would be called null. Some other languages, it's called nil, N-I-L. So this guy does not actually have a return type. That function doesn't return a value. Therefore, this dude just gets the default none because nothing came out of there, which is interesting. That is interesting that remove doesn't give us a... So do we have a find? So here's we can add an item to the list. We can insert an item at a particular position in the list. Yeah, so for remove, we would kind of have to use it in conjunction with index. So this guy returns the index of the first item in the list with value x. Or I'm guessing it's going to return a -1 if it's not found. Let's test that one. So we're going to go ahead and we're going to say, give me the index of 2. The first index where a 2 is found should be at index 1, position 1 in this list. All right, so the val should print out a 1 here because that's the position in the list where the 2 is first located. So there's our 1. Notice that we haven't removed anything from our list. All we did is search through our list and find the first occurrence of something. Now I'm going to go ahead, and this is really the more important use of this, assuming it works the way I'm going to look for a 5. 5 is not found in our list, correct? So I'm going to go ahead and we're going to search for a 5. And I believe this guy's going to return us a -1. I did not find it. Five is it gives me an error. This is a useless function. That's why it was on sale at Home Depot. Man, I hate that function. So the only way to use that effectively is with the try catch, which we're not teaching yet. That's a stupid function. I hate that function. All right, so given that, we're going to write our own. Okay, we're going to build our own index function for lists. There probably is one built into the language, but I don't use Python enough to. But you're kind of seeing here that hopefully I'm proving the point here that programming is programming, right? You know, I have a lot of programming experience, but not that much in Python. And I haven't used Python in a year, but you kind of figure out what tools you have available to you, and you solve all the problems using those tools laying around, right? So the index that I found sitting in front of me didn't really work the way I wanted it to work, but I thought, you know what? I can go and scour the documentation and look for the correct version of index or an index of or something like that that does exactly what I want it to do, or I can just write it real quick. It's not a hard function. All right, so I'm going to go ahead and I'm going to say def, we'll call this guy index of, and this guy will take in a list as a parameter, and it will also take in the value we're searching for. All right, and this guy is going to return either the first place we find that or a -1 if it's never found. So I'm going to search through every element in the list, and I need to know where we are in the list. So this is that example where having that index is going to be the index is going to be beneficial to us. So we probably want to use the for I in range pattern for searching through our list. So for I in range 0 to length of LST. So this will take I on a voyage between 0 and the last legal bucket in LST, because the length of LST gives me, if the list has 5 elements in it, this will give me a 5. But range says go from this value to this value -1. Each time through, we're going to ask the question, if the list at position I, the current element we're looking at in the list, is equal to val, go ahead and return the current value of I. I found it. I'm done looking. This is where I first found that element in the list. If I survive this entire for loop and I never find it, return a -1. Go through every element of the list. For each element, ask, am I looking at the guy that matches the dude I was searching for? If I am, go ahead and immediately end the function and return the current position I'm looking at. If I go through the entire list and never hit this return, I get dumped out of this for loop, and now I know I have looked at the entire list, never finding the value I was interested in, therefore I'll go ahead and return a -1, it was not found. So now I have a function that does what I want it to do. So I'll come down here, and instead of using the index that's built into my list, I'll call my version of index of, passing it my list and my 5, which is not found in there. And now this guy will give me my -1, because 5 is not found. So there's my -1. Similarly, if I go ahead and I'm going to search for a 2 again, this should give me a 1, the first location that a 2 was found. So there's my 1. And if I search for a 3, this should give me a 0, 1, 2, 3. The first occurrence of 3 happens to be at bucket 3. There's my 3. Make sense? So I could say I did this all on purpose, but this is kind of evidence that don't spend a whole lot of time scouring resources online and looking for the perfect function that solves your homework assignment. Okay. Chances are that's not going to exist in its entirety. There might be functions out there that will be beneficial, but as we mentioned, like the first week of class, you can fix a whole lot of stuff around the house with a screwdriver and duct tape. Right? And if you're 45 minutes from a Home Depot, it might be faster for you to fix something with a screwdriver and duct tape than driving to Home Depot, getting the proper tool, driving all the way back home, and then fixing it with the proper tool. You might have already been done. If you want evidence of this, you should see my VR chair at home. I should take somebody text me that and remind me, like around 8 or 9 o'clock, I'll be home. Okay. I have this chair in the basement that I use for VR because it's a full rotation chair, and because I have some back problems, I need to like push out in the right places so I'm not uncomfortable. I like ripped apart this like old mattress thing, and I have it just duct taped like to have head support, and I mean this is like the most comfortable VR chair you've ever been, but it's something that you wouldn't even buy at a garage sale if you saw it. Say this again.
Is it like the guy for that big bad guy in Ready Player One chair?
But it's not as nice as that. Yeah, but it's more functional than that. Because when I was playing the shooter last night, I mean, I'm like zipping around in the big, like, you know, because I can go 360 degrees. I have a whole harness system above,
Oh.
so I have wire management. So it takes the wire up to the ceiling, and I have pulleys off of that.
Mhm.
So you know, I'm not strangling myself with the wire. The wire's always above me. So I'm zipping around. Oh my gosh, it's a great leg workout.
Awesome.
That's cool.
But I mean, it looks really, really ghetto.
I mean, if it works.
Well, that's it. Yeah. So I mean, you know, some of you know, I have the money to buy a chair. I got the money to buy a chair.
Save money, but make
But the way you keep that money is not buying the chair.
Well, right. Plus, I mean, I have multiple problems I got to solve. I got to find a chair that has the weight limit, right? A chair that will rotate all the way around and not break under the weight. Okay, and it has to, you know, fit my body perfectly. Well, they're not going to make that chair, so I made my own. Duct tape, and I mean, it's legitimately duct tape, and just wadded up foam.
That'd be like.
So I got zero. I have the memory foam all over this thing. I mean, it's like comfortable foam. I have it built up on my arms too, so my arms are like at the exact height where I sit.
That sounds good.
Oh, it's just perfect. And I have this pillow in the backrest duct taped on there so it stays in the exact right position. Nobody else can use my rig. It's got this monster chair, and like, why is this like thing like somewhere in the middle of the chair for your headrest? So there's your evidence of kind of the MacGyver approach, and that's the similar approach you would take as a programmer. You know, let's take a language like one of the languages I probably know the best is Java. Okay, I've been programming in Java since the language came out. This is in, I don't know, 94, 95, 93, something like that. So you would think that I probably know quite a bit about Java. I doubt I've seen more than 20% of the language. There's zillions and zillions and zillions of tools, functions that are built into this language that solve every tiny little problem that was important to somebody at some point. I've never had a reason to use some of them. So most of the time, if I need something to work a certain way, I write a function that does it. I mean, was this that bad? And there's a function that does exactly what I need it to do. Now, my guess is there is already a version of that in Python. That's a pretty common function. I'm actually shocked that the built-in index function doesn't work that way. Okay, but whatever. So I'm sure there's that equivalent function there. But it might have taken me 5 or 10 minutes to find it, and it took me 1 minute to write it. So maybe it would take you 10 minutes to write it or 15 minutes to write it, but over time you would get faster and faster where this is like, you don't even consider it. Like, oh, I'll just write this real quick. That makes sense? So try to approach programming like that. One of the worst things you can do when you're working on your homework is looking for the magical function that solves your homework. Chances are when I've given you the homework assignment, I've considered the assignment I've given you something that at least I don't believe was built into the language. You have a better chance in Python of me possibly giving you something that is built into the language or not built into the language, but you know, whatever. Point is, all these the programming languages are all the same. You're at the mercy of just what functions are pre-built and what functions you write yourself. You could even have the policy that you never use built-in functions, that you just always write your own because you're a purist. That would be okay. Maybe inefficient sometimes, but okay. Okay, so questions about some of those function dealy flippy thingies. Now, what's interesting here is they've shown you, so for adding elements, we've used append. So this adds an element to the end of the list. We haven't seen extend, but extend allows us to effectively concatenate two lists together. So let's look at that here real quick. So I'll say my list, and I'll say my list 2 is equal to, I don't know, 5, 6, 7. Let's just keep it simple. And then I'll go ahead, I'll print out my list, I'll print out my list 2. And then I'll go ahead and say mylist.extend mylist2. And then I'll print out mylist. All right, so they're two individual lists at first. Now let me show you this. I'm also going to print out mylist2 again here at the end. So we have two separate lists. Here's the original mylist. Here's the original mylist2. We should print those separately initially. Then we're going to say I want to take my list and I want to extend it with mylist2, which should take these elements and tack it onto the end of my list. So my list should have an extra 5, 6, and 7 at the very end of it, permanently changing my list. So when I print out my list here, it should be 1, 2, 2, 3, 2, 4, 5, 6, 7. But when I print out my list 2, it should still be 5, 6, 7. This should not have modified my list 2. That's the way I think this should probably work. All right, so here's my two separate lists. My list 2. Here's the result of my list after I called mylist.extend mylist2. So now we've permanently tacked those elements on. We've permanently concatenated some the contents of mylist2 onto the end of my list, permanently changing my list. But notice that mylist2 is still the original. We didn't damage that at all. Make sense? All right, so that's extend. All right, so this concatenates the contents of another list onto my list. I don't want to have to spell it permanently. Changing my list for good. And leaving another list unchanged. All right, that's what extend does. All right, we've seen append. Append tack something onto the very end. Now insert. Insert X into the list before a specific position I. So we're going to put this value into whatever list is before that bucket I. So let's say that I'm going to put this is bucket 0, 1, 2. This is bucket 2. Let's say I want to put a 7 before bucket 2. I'll go ahead and say my list dot, what's the name of the function? Insert. Dot insert. And then I give it the position first, where the guy who I want to insert this value before. So I'm going to say before, this is 0, 1, 2. So before bucket 2, I want to insert a 7. So before bucket 2, insert a 7. So now I should have a 1, 2, 7, 2. There's my 1, 2, 7, 2. Make sense? All right. So risk of a quiz on Friday covering these list functions. You will have a homework assignment over the weekend where you'll have to use some of these functions. So go home, study these functions, be prepared for a quiz next class. Also, Bible homework is already up, and that's due, since I got it up a couple days late, I made it due midnight Sunday.
Okay.
All right. See everybody on Friday.